coffee break. I hope you enjoyed the coffee and the cakes. And second final talk today is given by Johanna. Some of you had the chance to listen to Johanna's talk about costumes during the last summer school, and what she's now doing is she's going to present to you the progress we made over the last year. So we developed a costume repository, we developed a solution repository, and she again gives an overview, and we did something more. We have a mathematical theory of costumes, but we are not presenting it. So the talk today is about the generic stuff that we are doing at the Institute, pattern and solution repositories. Yeah.
Thank you very much. Nice to be here again. I had last year the privilege already to show what I'm doing in costume. Today I want to present our pattern and solution repository. First of all, I want to start with a very short defining of patterns, since patterns are always... oh, something is wrong. I want to give a short defining because there are a lot of different ways how patterns can be used. And this morning, Gerd Breiter already talked about patterns. It was quite something different than what I'm going to talk about. Then I want to show how we approached our pattern repository, and then give a short demo of our pattern repository called Patternpedia and our solution repository called Muse. So we start with defining patterns. First of all, pattern is something very simple. Patterns are defined as a proven solution for recurring problems. So they are a concept that aims for very abstract knowledge capturing to present this knowledge in a very high-level way that it can be applied to different areas again to make it reusable. But the pattern is not just standing alone. Each pattern is related to other patterns. So the pattern and its cross-references to the other patterns together are pattern language. To give you an idea how these patterns look like, I brought the format for the costume patterns with me. So each pattern has got some special areas. It's most of the time a textual description of this abstract solution. And the costume pattern, for example, we've got the costume pattern for the sheriff. It has got a name, of course. It's a costume pattern for sheriff. It has got an icon, as you can see here. It has got a purpose. So why do we need this costume pattern? It has got a composition, which is actually the solution for clothes. When you look at someone who's dressed, there are a lot of special items. A trouser and a shirt and some shoes, and all these things has to be composed to a certain costume. So this is why at the costume patterns, the most important part, the solution part, is the composition. Then of course, every pattern has got some forces. Why is it difficult to solve the problem? It has got a context, where does this pattern occur, and it has a description. There are some additional information which can be also filled in with information. But this is how most patterns, even in different domains, look like. At the IAAS in Stuttgart, where I'm working, we are doing pattern research in quite different areas. We did a lot of research in the cloud computing pattern area. We did green IT patterns, we did research on data migration patterns, and what I'm doing is the costume patterns. I'm not a computer scientist, I'm actually a media scientist, but I somehow try to use this pattern concept for costumes, and it worked very well since yet. So how do we gain these patterns? Patterns, as I said, are a very abstract solution. So first of all, when going into a domain where you want to find patterns, you have to take a very close look at the concrete solutions there are. In films, it's very easy, since every film, every costume is a concrete solution to a problem a costume designer has. The costume designer wants to find a good solution in dressing a person to communicate the information he wants to give on the person. So here, for example, when we look at Western movies, there are a lot of concrete sheriffs, and these concrete sheriffs can then be abstracted into a sheriff pattern. This is the whole idea. It's quite simple. When we look at this in a bit more abstract way or in a general way, there is always one pattern which is abstracted from a lot of different concrete solutions. So the pattern is just an advice. It's a very high-level description, as I said, and it's just context-free. So it's not written for a certain context or a certain environment. And if you want to implement it, it takes a lot of effort to implement it again. So this is why what we want to do is to link the pattern to the solution it has been created of, so that when applying it again, it's more easy because you've got some information how to implement it in a certain environment again, and how others did this step already. So next, as I already said, each pattern is not just standing alone, but each pattern has got different patterns which follow the same format, but they are related to each other. So the pattern language has got more than just one pattern. And for the costumes, for example, the sheriff costume is related or often goes together with the outlaw, and they're both in love with the saloon lady, and the saloon lady always appears with the bartender, and so on. You get the whole storyline of a movie just by the characters. This again, of course, can be shown in a more general way. Then we get a pattern language graph, for example. So here we got the patterns, and we got some relations, and they could be, like we saw the costume patterns appear together or are formed of, or they can be the cloud computing pattern, something like consider after or is connected to. And of course, when you look at the graph, you need to somehow support to go through the path. And this is what we want to do with our pattern repository. Of course, we want to support finding the right pattern path to navigate through a pattern language. At the moment, we are doing with Christoph's group, with the University of Crete, some more research on this to support the pattern path by advanced mathematics, but this is not my part. So we'll see maybe some new things next year on this. Now I want to go a little bit more deeper into our approaching the pattern repository. As I already said, at the moment when we're creating a costume pattern or a pattern language, and in general, there's always a domain expert who has got all the solution knowledge. So here we got the domain expert who observes what's there. He has got the solution in his head, more or less, or it's a group, and they analyze and abstract their information they've got on the solutions and create an abstract pattern language. So what we want to do in our first step is to store both of the informations there are. To store as well the solution knowledge that experts have into a structured a solution repository, here we go, and to store the pattern language in a pattern repository. When working with patterns at the moment, this way isn't supported. So what we want to reach by capturing the solutions in a structured way is to use some new analysis techniques like data mining or querying and so on to support this identification process that takes place to reach a pattern. Yeah, we're working with patterns at the moment. There are already some pattern language repositories, but they don't really support the navigation, and they're not generic, so they're most of the time just for one pattern language. So we want to support a format where you can just easily adapt it to the domain you're working with. And of course, what we want to do with this solution knowledge is not that you not only, when working with the pattern language, need to find a new solution again, but to improve this a little bit by going back to the solution knowledge that's already there. So we want to link the patterns to all their solutions, the concrete solutions there are, to make it more easy to apply the pattern again in an environment, in a certain context. So, what we did is to build Patternpedia. You can find more information on Patternpedia here on patternpedia.net. And this is just an overview of the architecture of Patternpedia a little bit. We've got different roles who can work with this system. First of all, again, there is this domain expert, and he has to structure the information or the domain. With the costume patterns, we did a quite big ontology on all the costume relevant parameters, like what colors does the clothes have, which materials do we have, what sort of clothes are there, and so on. So it got quite big. This was the first step, and then this structured domain knowledge can be imported into our solution tool. This solution tool is very domain dependent, while our pattern tool, which comes in the next step, is domain independent. This is dependent on the domain because every domain needs some specific structuring and has very specific information. For the costumes I need something very different than when talking about clouds. But in the abstract, in the higher level as the patterns, you can just put it together in one repository. This is why here I'm going to show our solution repository for the costumes already. Well, I stopped here, so the solution knowledge can then be collected by the solution collector. This is what we are doing currently for the costumes. There are a lot of people just watching movies and keying in all the costumes. And then the solution knowledge can be used to abstract it into patterns, which are stored in the pattern repository, of course. But here not only new patterns can be stored, but also existing patterns can just be imported into it. And on top of everything, there is a method model to keep it stored in a structured way. But what I want to do is to focus on these two parts, on the solution and the pattern repository. So in the pattern repository, of course, there are all the different patterns and the links between them, as I showed with the costume example, and they are then linked to the known users, to the concrete solutions we found in the movies. And as I said already, on top there is this meta model to structure this and to give the possibility to run the queries on top of it and so on. First of all, we take a closer look at the pattern repository on our Patternpedia. At the moment, in the web, you can only find it for cloud computing patterns, because with the costumes we've got a bit problems with the pictures. They're copyrighted and so on. We just a pattern, the cloud computing patterns you can find, but under cloudcomputingpatterns.org. It's a tooling which is based on a MediaWiki, which is actually also used for Wikipedia. And it has got a pattern format, as we can see. Here are the icons of the different patterns for the cloud computing patterns. And if you click on one, you get into the pattern itself. You've got the pattern format, quite similar to the one I showed for the costumes at the beginning. So it has got a purpose, it has got a problem statement, a context. And here are the links on the side. We will see this a bit closer at the demo later on. Our solution tool on the other side, called Muse. Muse is an acronym for a German Mustersuche und Erkennen, which means as much as pattern search and identification. And it's this is the architecture of Muse. So it's got a front end, of course, and a back end, and it's a browser where the not-informatic people like me can key in the information. And it's based on JS Angular and stored on MySQL. And what we're doing currently, we are working very much on this part to build that data cube, and we want to use some data mining algorithms to get some information out of it. So to use the information put into other costumes, to use it to get the patterns of the costumes out of the system. The Muse tool itself looks like this. Here I have to apologize, since I'm doing my research in German, the content is German as well, but I will just explain it a little bit. So this is just the overview of the film. You can see a picture of the film and some information on the film, and underneath there are all the roles, all the characters which can be found in the film. This is probably where we just switch into the real tool. So I will just start showing you the cloud computing patterns. This is quite similar to the picture you saw in the screenshot already. Here we can see all the different cloud computing patterns, which are just seen by the icon, and when you click on it, you can get deeper into it. As we can see, it has got a statement, it has got a problem, a context, it has got the most important part, the core of every pattern, of course, is the solution. And here on the other side, if I'm too quick to say, on the other side there are the links. For example, if you've got this pattern, we should consider next the other patterns. If I just click on this, I'm already at the next problem, on the next solution for this problem. And the same is possible for the costumes. I've got the costume patterns here, and they look quite similar. So in this tool, it's very easy to define the format for the patterns you need, and to key them in, and to define some new links between them, so you can support the navigation through it and to work with the pattern language. So here I've got again the high school queen, for example. She's a beautiful lady everyone wants to be friends with and wants to be liked by her, otherwise you've got a problem at the high school. And it occurs in a certain context, of course, in the genre high school. And the most important part is how this costume is composed. So we've got a whole costume, and we've got some primitives that compose the costume. All these things, of course, have to be keyed in or have to be captured from the costumes when looking at the movies. And what's the important part now is we've got here now the section known uses. And here I can get from the pattern directly to a very concrete costume, which we found in the movies, which was used to abstract this costume pattern. So I'm now already in the Muse tool. It takes a little bit because of the environment. And we can at least switch names to English, but and here I can see now already some pictures quality. But if someone wants to see it, I've got the tool here, and I'm still here the whole week, so just come and ask. I've got now here different pictures, first of all, of this costume to see different parts of the costumes. I've got a lot of information on where is the costume worn, and quite important at which times in the movie did I find this costume, and this is important for the abstraction, how long is this costume seen, how important is this costume, and so on. I've got a lot of information on which color does it have, which is the main color, which are the sub-colors, on the function it says, on is it dirty or is it torn, which conditions does it have. And I can just key in things if I want to. I can just give her a character try maybe this mean. So I can just type in gemein, which means mean in German, or I can use tree view, because I already said we've got a big ontology behind it. Each field can show a little bit of this ontology, more or less a taxonomy of these options which can be used in this field. So here you can see all the different character traits, for example, which can be used to describe her. Next to this I've got, of course, information where is it set, how old is she, where is the movie set. And the core, again, is here now the composition. So these are the whole primitives she's wearing. She's wearing a top, she's wearing a skirt, she's wearing a belt, some shoes, and so on. And again, when I go one level more underneath it down, there's a detailed description on what colors does this skirt have. Is it very slim or is it wide? Again, which materials are used? How does this material look like? Are they thin or are they thick? Are they stiff? And the same with the colors. It's pink and white, and is it a strong color or is it just a weak color? So we need a lot of different information to later on use this tool, use these concrete solutions to abstract some patterns. This, and again, each base component, like a shirt, has got a sleeve, it's got a color, and so on. So it gets very deep down and really try to capture a costume in every detail. Now we got into the Muse tool by a pattern. The normal entry is through the film names. So you can just see here we're working on quite a few films already. And here you can just create a new film and type in the information on the film. You can create some rows, and so you can capture all the information you need. So this is actually what I wanted to show you. As I already said, if you have questions, I'm here and happy to show someone in more detail. Let's get back to our presentation, which is So just to summarize it quickly, what I wanted to show is our method, or our new method, to capture patterns by also storing the concrete solution, because it's a big problem when working with patterns that they are not verifiable, that they are not, their pattern provenance is always a big thing. So we wanted to make them verifiable by having the information where they got abstracted from. And we also wanted to open the possibility to improve the way of finding patterns, because normally there's just an expert who says this is a pattern, and someone has to be a little bit more precise. Where does it come from, and how can we connect this information together? And this, hopefully, by using the repository, should improve the work with patterns, improve the navigation and finding a pattern path through the language, and of course improving the application of patterns again when using the concrete solution. For the costume area, it's very interesting. We talked a lot with costume designers, and they're very interested in it because the research in the costume area is not supported anyhow. So this would be a good thing for them to have. And we hopefully have a lot of costumes in it by some time. Thank you.
Thank you. Are there any questions? Oh, since you were working on
Okay, so Johanna.
yeah, go on.
So one of the things that we were discussing with Frank was that I think you said that also yourself, that in addition to the archiving function of this database, you also want that database probably as a tool for new producers or new directors or whatever. Directors.
Hopefully for the costume designer, yes.
For the costume designer, for new movies, and so that they can produce new costumes, I guess.
Yeah.
So now, if you follow the patterns and solutions idea, then it might be possible that you have several alternatives to choose if you want to.
Yeah, that's the whole thing.
Right. So, is there any way to express preferences in a particular context for one costume versus another?
Yeah.
Because, I mean, the reason I'm asking that is, if you can do that, then you can also try to express that in terms of utility, functions, and so on.
Yeah.
And therefore, speed up the search.
Yeah. Yes, we're thinking about this like and dislike for the costume patterns actually, but this is something different. I know the costume designer, they don't want to have too much support. They still want to be creative. And this is why they fear a little bit that this is too much automatic, giving them the costumes and every movie looks the same. So this is why I really like the patterns, because it's just abstract, giving them some first ideas. And the concrete solutions are more or less more for research, knowing what the others do and not taking one and implementing it again. So therefore they're probably more into it, helping them to find the right costume by the time the movie is playing, or by is it a nice character or is it a bad character, and so they can narrow down to the information they really need. But they don't want to have an Vorschlag?
Too much guidance.
Proposal, yeah.
So I'm basically no room for what you answer. So remember the slide that she had, you have a pattern that is connected to solutions.
Right.
And this connection also may wear some, maybe decorated by weights. For example, the cost of the costume.
Well, this is like the other criteria that I mean, like the time and
this is what he's asking for. He's
Yeah.
asking for, is there some additional information that I can use in order to spit out an optimal solution if you have a low-cost production? Then he can basically say, okay, you don't need to consider the 50 costumes, so take a look at the 3 costumes, they apply.
And this would be very interesting when connecting it with real costumes. Since we already talked with a costume, it's not a costume vendor, they just rent costumes, but it's a very big company in Germany. They do a lot for film and theater and so on. For For costumes, yeah. And they are huge. They are like, I have no name. And they are interested in connecting some of these items with real costumes, so someone can use it as for research and also renting the costumes straight away when they see them. So there it would be very interesting to find the right costume or narrow it down to the use. Yeah. But this is still far away, I think.
Any more questions? Thank you very much. And we now have Cataldo. So University of Stuttgart is happy to support IBM.
Yes.
Because they can't afford a pointer.
As usual.
As usual. So we will charge them later on.
As usual.
So now on stage with Cataldo Mega. Cataldo Mega is also a senior technical staff member at IBM at the Building Laboratory close to Stuttgart. And he's working since I know him. That means he's as young as I am, 40 years. So he's working on content management. And his talk is very lengthy. It's called Dynamically Adapting the Deployment of Productive Cloud Services for Minimizing Resource Consumption and Still Meeting Certain Objectives and Performance Goals. And this was so exhausting that now the stage is yours.
Yeah, thank you so much, Frank. So I'll stick with 30 minutes, so my session will not be lengthy. The title is lengthy. But I will try just to stick with the 30 minutes or so and try also to convey the gist of what my 40 years with IBM would be. So I'm really excited actually because since this morning I'm hearing all these nice sessions, and this is really giving me a lot of insight that I didn't have. Yeah, you're a computer scientist, I'm a physicist, so I don't know anything about computer scientific stuff or so I'm learning quite a bit. But I consider myself as a subject matter expert in enterprise content management solution. So I've been working in this field.
Go ahead.
In this field for almost 20 years or so, but I've been with IBM a little bit longer, as Frank was saying. What I wanted, and this is really interesting because we heard Frank this morning, for example, Gert and Michael before, which was more the aspect of how IBM is positioning this. And then Frank came in and discussed a little bit about the theory of all this, what is cloud computing, how can we efficiently use it. He spoke about, like easy of use and the promise that cloud is giving also. Then we have seen some example, which is nice, so like the deployment of topology, how easy this whole thing is. And I will show you that it's not easy. It's blood, sweat, and tears, as Frank was saying. And I'm really open to you guys to help me out with, because I'm trying for several years now to make it easy for businesses to go into the cloud and consume services in an easy way, but I haven't found the means of doing so. So if anyone wants to come and help me, I'm in Böblingen at the IBM lab in Böblingen. I'm working very closely with the University of Stuttgart, specifically also with Bernhard Mitschang. And just come by and help me out with deploying real production services into the cloud.
Very easy. If you have funding, we will come.
We will talk about the funding later. Okay. So yes, I have a solution. I'm a subject matter expert. I'm an architect. I'm paid for that also, and not bad actually. But I cannot afford to buy a pointer. So I will show you, what an architecture of a real customer looks like. My customers are coming from the financial area, so banks and insurance mostly. I've worked several years also with governments or governments, but banking is really the background. And I'll show you a real application, a real solution. I'll tell you also about the difficulties we had to define a topology, to bring it into the cloud, to come from a classical solution developed inside for on-prem but now, with the pressure of cloud also moved it into the cloud. There is a service out there in the cloud that we are offering to business customer, enterprises or so. And we are trying to get into the public cloud, but are having a lot of difficulties there, and I'll talk a little bit about it. So let's move into this. I'll give you a little bit of motivation. There is not much really for me to say except what was said today. I'm just emphasizing one thing, that this promise that is coming with the cloud, coming from a business to consumer, right? And business to consumer means you are really getting everything for free, which is not true, right? You're giving your privacy, you're giving your information, you are the victim, so to speak, not the customer for these guys, therefore it's for free, so to speak, right? But this is a very nice model, it's working properly and everyone likes it, and so the businesses are looking into it and saying, how can we adopt this model as well for us, for the business to business? So the Cloud 3.0 or so, in a provocative way.
It's not the first time, it's Cloud 3.0.
Yeah, Cloud